Yeah. All right, guys, get this one down in your notes for me, please, okay? So we're going to try to get through 3 examples today. I can't guarantee we're going to get all of them solved all the way. We're going to try at least to get through 3 settings, okay? And you'll have a fire problem or this stuff again on Wednesday, so I'll help out some too. Good with everybody, right on lunch? Excuse me. Okay, everybody have a chance to get down their notes? Okay, get a rough picture of it, put it in your notes so you can look at it. I would mark the text a little bit if I were you. Let's focus on, right now, just part A, if you can. Okay? Just focusing on part A, not worrying about part B right now. Okay? And then just part A, just defining the variables running the system. All right? We'll solve it together in a few minutes. Right now, just trying to figure out how to separate all the information is going to be key here, okay? We want to make sure that we are identifying the 2 categories of information that we have for this problem. Because we talked about that a little when we did the graphing problems, right? That usually for these we'll have 2 different categories of information, and we need to try to separate what we are given into those 2 different categories, okay? So I'll give you a minute to look over through some things, and you have a minute to check over with your group mates on some things, and we're going to talk about it together, okay? All right, check with your group mates, see what you guys all come up with, okay, on how you should organize this information, and we'll talk about it in a minute or so, okay? So discuss with the groups. Let everybody move at once. You won't let me stop you. Okay. You just want to check to the chase and talk about it together then? Is that what you're kind of motioning to me by not talking about it in your groups? You just want to talk about it together? We can do that. That's fine. I've been reading body language of kids for 19 years. I think I kind of got the signal on that one. So, all right. You guys ready to go here then? Okay. So, what are the 2 categories of information we have here? Who's been able to separate this out just a little bit for me here? Caitlin, why don't you figure out? What's one of the categories here? Okay, so we have orchestra level tickets, right? And knocking level tickets. Okay. We're trying to figure out the price of each one. That's what we're trying to solve for here, correct? All right. So when I'm trying to find my variables here, I'm just going to put them right down here. What is it okay if I use x and y? Okay. All right. So x equal what? Caitlin, you raised your hand and took some and help me out. So you determine what x is going to represent. We're going to find the price of each ticket. So is this going to be the price of a balcony ticket or an orchestra ticket? Balcony? Okay. And you could have easily defined it the other one, as long as y then is the one you didn't define for x. Okay? So either way. Are you okay with that? All right, who do you think is going to formulate one of the two equations we need for this system? One of the two equations we need. Brandon, give it a go here. Are you letting X be an orchestra ticket? It could be for you. I just got to know, make sure you're setting it up the right way. Then you're correct. That's fine. Okay, we're gonna change those around just a little bit so it follows what's up here. But that's the correct setup. Okay, Eliza. It very well could be, even again on the setup here we have. So let's double check that here in just a second. Let's get this first one here going here. But you guys seem to be pretty good on this already. This is great. So we have, for us, it's going to be 76x plus 148y equals 3,640. We'll go with that one. Okay. And then Eliza thinks, now here's the thing. Let's go ahead and get this information marked up here too. They earned 3,640 from a concert. Sold 148 orchestra and 76 balcony level tickets. That's all about equation one, right? So I'm going to put up here sales. All right? That's how much money they're going to make from selling all those tickets. Sound good? All right. The other one's about quantity, right? All right. So it says an orchestra level ticket costs 3 times as much as a balcony level ticket. All right. So an orchestra ticket was what variable up here? Is it X or Y, kids? For us, for up here on the screen. It's Y, right? So Y then would equal 3 times the cost of a balcony ticket. So for me, it's Y equals 3X. Now, if you set it up like Brandon, though, okay, then it's X equals 3Y. Does that make sense? Because Brandon had X equaling an orchestra ticket, and we have X equaling a balcony ticket. So everybody see how this works? Show me a thumb. Are you okay with everything? Solve it. Oh, wait a minute. Before you solve it, let's determine what method we're going to use. Raise your hand if you're going to use the graphing method to solve this. Good. I would have to come down and give you a little bit piece of my mind if you decided to go that way. So I'm glad you decided not to go that way. Raise your hand if you're going to use substitution to solve this one. I would too. Next job. What give it away? Why give it away, Wyatt? Very good. Yeah. When we have an equation where a variable is already solved for it by itself, then it's a good time to use substitution. Very good. Okay? Okay. You guys go to work. We'll see if we can get some answers here, okay? 148 times 3. 444. Okay. Just make sure you bring down your variables with your terms. These both have an x in them, okay? Some students sometimes forget to carry that x down, then they run into a bit of a snag. So be careful with that. Don't forget to show your work. Is it 520? Those cancel out. I'm left with what value for x? Raise your hand if you got it for me, please. Emily? $7? Sound good? Okay. So then I'm going to use equation 2 to find y. Okay? It's real fast. You get y equals 3 times 7. So y equals 21. Are we okay with that? Okay. That's how you solve your system. So what's the answer between the x equals 7 and y equals 21? You can help me interpret that answer, please. Sadie?
The price of the orchestra ticket is 21 and the price of a balcony ticket is 7.
And if you have Brandon's setup, you should have y equals 7 and x equals 21, which is still correct the way he defined his variables. Okay? So that's why defining your variables here is important, because you could have let x be either price, okay, either ticket price. So that's why it's important when you define your variables on your assessment, that's just coming up pretty soon, that you specify what specifically your variables represent. Okay, so I don't have to second guess whatever it is. I'll be okay with you not whatever way you want to go. You just got to tell me which way that is. Okay, so, like I said, we let X be a balcony ticket. Some other people let X be an orchestra ticket. You just got to let me know that in your definition. Okay. All right. You guys think you can handle some of these? I got 3 for you for homework for tomorrow. Okay.
Great.
Okay. Hey, it could have been 7. I just said 3. You're welcome.
Yay! I said 3 is great. 3 problems.
So you haven't seen the third one yet either, so you might want to hold on to that thought. You know me. You know me by now. I'm not going to share all my tricks right off the beginning here. Okay. You guys ready to try the next one? Okay. So I'm just going to recap this real fast. So, I could spell balcony ticket cost $7 and orchestra ticket cost $21. We okay with that? All right, you guys ready to try the next one? Sure. I can hear you all the way from over here. You guys are so excited to try the next one. Uh-huh. It's that whispering excitement. Okay, get this in your notes. Okay, so I did here, but this time you're going to do some group collaboration on this one. So why don't you guys work together in your groups and get your variables defining your system in. Okay, I'll give you about a minute and a half to make that happen. Mark your text, and we'll talk about it on the other side. Okay, 90 seconds, go. I want to hear some conversation. Thank you, Wyatt.
And then there's a large truck.
Location.
3 large trucks.
Location B receives 4 trucks. So if this is only location A and location B. So location.
Right now, I think it's
And then we can which one do you want to be actually putting
Okay, that kind of fizzled down. Are we ready to move on? Sound like we were in pretty good shape here. Now, the nice thing about this one also is that most of the time on these, what I've noticed, I'm going to give you a little bit of advice here, okay? Over the years, I've noticed that usually when you have a systems part like this, you usually hit one sentence per category of info, okay? And that's the case on this one here if you get it set up correctly. So, that's it. Not all the time, but sometimes, okay? You can use each sentence in the system that gives information is about one category of info. They don't usually like to mix them together. Okay, so that's good to know. All right, so I will select to hear from some. Of course, I roll Merrick's number. He's not here today. I can roll anybody in this room except for 2 people. And I roll the one person that's not here today. Go figure. Okay, we'll talk to Lance. Lance. Okay. What is your? Did you use X and Y?
Yeah.
Okay. What does your X represent? Okay. Number of large, is it, cost of large truck. Yeah, it says down here in part B the cost. So I'm giving you that. I'm giving you that one too for there. And so that means Y is the cost of a small truck. Okay. There we go. All right. I want to roll again here. Find somebody else in the room. Now I rolled doubles the first, and now I rolled Lance's number. Jeez, tell you what, I am not having good luck rolling today. Until now, Tony. How about one of the equations, please? Are we able to figure out what one of the what does each equation represent? Are you able to figure that out? Mm-hmm. But how do you set up your system? Each equation in your system represents what as a part of the system? That's correct. Nice job. Yeah, good. Okay. Can you give me your equation for location A then, please? Okay, hold on just a second. This is going to be equation 1 is for, I'll just put location A like that, okay? I need another 0. Thank you. I'm in trouble later on. Okay. I like to, sometimes I'll drop a 0 on those larger numbers. Tony, you did so good. I'm going to let you do number 2. All right. Show me a thumb, guys. What do you think? Are you guys okay with this? If you let X be a small truck and Y be a large truck, everything will be a little bit reversed, okay? But that's the only thing that'll be different about it. Setup should still be the same. Everybody okay? Now, show me on your hand. When you raise your hand, I'll give you 3 methods. You tell me, you raise your hand which one you're going to use to solve it, okay? Substitution. Really? You sure? No, I'm kidding. No. That's not. You don't want to use substitution on this one. That's going to be kind of. That's okay. I didn't mean to. I didn't mean to throw you off your game. I was messing around. No. Graphing. I don't have time to graph these. These are large numbers. Are you kidding me? How about elimination? I would go with elimination on this one. Okay. Nice job. You get it going here, guys. I'll catch up with you. And again, you can choose to eliminate X or eliminate Y. It doesn't matter. You can there's like 4 different ways you can solve the system, and every way could be a correct answer if you do it correctly. Okay, depending on what you choose to eliminate and how you choose to eliminate it. So, I will know all the correct ways on your assessment. You just gotta give me one of the correct ways. Okay. Everybody doing okay so far? It's awful quiet in here, which is not a bad thing. I'm just making sure everybody's okay. Everybody good? Okay. I forgot a negative sign on mine. Now it's there. Okay. So I get the cost of a large truck equaling $60,000. How's that sound to everybody? Sound pretty close? I'm just going to use equation 1 to find y because it's convenient. Okay? You could use either one. And I suggest using the original ones. All right, compare your answers with your group mates. Make sure you guys are all on the same page.
Yeah, just can't do that.
Okay. Oh, sounding good, everybody. I was overhearing on the conversation. So, RJ, can you help me analyze your answers here? What do the answers mean?
So I got 60,000 for x after eliminating my limit
Mm-hmm.
by multiplying equation a by negative 3.
Okay.
Equation b by 2. Y.
Okay.
Then I'm left with negative x equals 60.
Okay. What do the answers to 60,000 and 45,000 represent?
The amount of money it costs for a big truck.
Okay, very good. So a large truck costs $60,000, and a small truck $45,000. Okay. All right. Everybody good so far? So you've seen one setup for substitution. You've seen one setup for elimination. Now we're going to get a little more involved here with a couple of things. I'm going to show you another example that we're not going to work right now in class unless we have time at the end of the period. All right? Because I want to skip number 3, go right on to number 4 for right now. Because number 4 is there's one just like it on your assignment, and I want to make sure we're in a good place for that. And if we need to, we can come back and hit one like number 3 for fire up on Wednesday. Okay? So I'm going to show you 3 because I want you to have it in your notes, but I'm not going to do it in class right now. All right? This is a good practice problem. So get this one in your notes. Oh, great what? Oh, you're telling me that you don't really like percentages?
I forgot how to do these in my 5th grade.
Oh, really? You don't like percentages? We're going to love the next one. Because
I don't like small percentages.
you don't like small percentages?
They're
Well, I can guarantee you that the next problem, there are percentages that are larger. Then how's that? See, we aim to please. We aim to please around here. See? Okay, you guys ready for number 4? This is the one we're going to work now, number 4, okay? So here's the one I want to work now with you guys.
Are there going to be questions with percentages on the test?
I'm not ruling anything out.
He said this one would be like the test. I'd assume so.
But don't let this get you down before you even get going here on it, okay? We need to go over some things, and I think after we do that, you're going to probably be okay with it. It looks intimidating, but it probably will not be so bad once we go over a couple of things, okay? So again, why don't you guys talk about what the system's going to look like in your groups, and maybe try to start drafting a system for this one, okay? And then after you guys got a minute or two on that, we'll talk about it, and we'll go from there. So, talk with your group mates. I want to hear some good conversation, and we'll go from there.
How about we just label everything? Get our equations.
Whatever works for your group is fine with me. I moved it up for a minute. I forgot to mark my text on this one, guys. I'll move it back down in just a minute. There you go. There's your problem. This happens all the time in pharmacy and chemistry. In pharmacy, especially, that the medicines only come in certain amounts, and they have to mix them together in order to provide the right amount for their patient. So they have to use the correct quantities of a couple of them and get the right amount of each of them to get the solution to the right percentages and that kind of thing with the right quantity. And that is actually a systems problem. Okay, and it's also a chemistry problem. You'll be doing some of this in high school chemistry probably too. Okay, so you'll have a head start because you know the math behind it already. All right, so let's talk. Okay, Mason, what were the variables? You have absolutely no idea. Okay, well, what do we need to find? Read part B. Milliliters of each solution, right? Okay, so the goal is to get a solution of 200 milliliters, okay, and 20% of that is alcohol. All right, like medicinal alcohol. Okay, I thought I may have to disclaim that just so we all are okay with everything. But this is not my first rodeo. All right, so I'm gonna make this tall so we can get the problem up here too. Start marking some things. Okay. All right. So, oops, I need to change my pen. There we go. So let's define our variables here. Okay. So x is going to be what? Who can help me out with this? How about some hands in the air? Eliza, what's x going to represent?
25%.
That's what you want x to represent? That's okay with me. Okay. So x equals amount of 25% solution. Okay. And that means y is what percent, guys? 10. Okay. And again, you could reverse these. It's perfectly fine. Okay. Now, were you able to get an equation? Was anybody able to generate at least one of the equations for the system? Okay. Emily, how about regarding to the number of milliliters you need in your final solution? Were you able to get that equation? X plus y equals 200. If you need 200 milliliters, and you need a certain amount from the 25%, you need another amount from the 10%, the total has to be what? 200. Okay? So the first equation is about quantity. All right? Make 200 milliliters. Whoops, I want an arrow. Make 200 milliliters of a 20% solution. Okay? All right, so our first equation will be x plus y equals 200. Okay, so does anybody have any ideas what the second equation is going to be like? Or is this where it everybody kind of got stumped? Excuse me. I see a lot of I'm not sure faces out there in math land. We're not quite sure what to do next. It's kind of a stumbling block for us here at the moment. What information haven't we used yet? Help me. What kind of information haven't we used yet? Okay, RJ? Well, we actually have used that already for equation one because this equation one here is about the total amount of solution I need. Okay, so the number of milliliters I need from the 25% solution plus the number that I need from the 10% solution equals to 200 altogether. Okay, so this one is about quantity. Okay, but there is another relationship given to here that we need to interpret and generate an equation from. Okay, anybody want to take a guess at it? What might be? Emily? Say one more time. Well, okay, elaborate on that. Could be, depending on how you're defining that. Yep. Okay. Yep. You need your final solution needs to be what percent alcohol? 20. Okay. So the amount of milliliters that are alcohol from the first solution plus the amount of milliliters that are alcohol from the second solution, okay, has to equal 20% of the overall solution. So check this out. We're going to have 0.10x. 10% is alcohol for the... No. I'm sorry. I did that wrong. I'm so used to doing it the other way. It's 25, right? Because it's 25% for x. We define the variable. Are we okay with that? I'm sorry about that. I was so close. I'm always used to doing it with 10% being x. That's okay. Okay, and then what's going to be the decimal before y this time then, guys? 0.10. Okay. And then the final percent alcohol is how much? What's the final percent? And it's 20% of the entire amount. How much is the final amount? 200 milliliters. So it's going to be 20% of 200. Okay. That's the little twist on this one, that little last part there. Okay. The 20% of the entire solution is alcohol. Okay. 25% of the first solution is alcohol. 10% of the second. 20% of our final solution has to be alcohol. That's how we get this one set up. Okay. So I'm going to write up here percent alcohol. Now, this might be a little nasty at first to solve, but if you know a couple things about how to work with decimals, you can make this a lot easier right off the top of the starting gate. Okay. What can you do to eliminate the decimals in this problem? Make it easier on yourself. Sadie? Mm-hmm. Yeah, exactly. Yeah, if you multiply each term by 100, which means to move the decimal point twice, okay, then you limit your decimals, and then it's a lot easier to solve with the elimination. Or you can even make a case for substitution on this one, okay? Because in equation 1, both of your coefficients are 1. That makes it easy to substitute also. So in this one, it really is whatever choice you wish, okay? But you have to solve it using one way or the other, okay? So when you have a problem like this, we're talking about like a chemistry type of setup, okay? You're going to kind of follow this particular format here. You have a problem like this on your assignment tomorrow to practice with, okay? But I have the answer key for you too, so you can use the answer key to check your work if you need to. Show me a thumb if we're okay with the setup here. Could you duplicate this on your own tomorrow? That's the question. Okay? Try it, and let me know how it goes on Wednesday. All right? Practice. Practice it. All right? Let's go ahead and try to solve this one now. So I'm going to multiply each of these terms by 100. Here, there, and there. So I'm going to have a new equation 2. I'll write down my equation 1, x plus y equals 200. Spread this out a little bit here. Maybe, if it'll let me. There we go. All right, and then for equation 2, I'll have 25x plus 10y, and then I have 20 times 200, right? What is 20 times 200? What is 20 times 200? 4,000. Mm-hmm. Yep. So I'm writing down the same system again. And this time I'm just going to change that last number here to 4,000, and I'm going to solve it for x and y. Okay? Now it works just like the ones that have been all the time. All right? So I'm going to get some people to help me out here. Alex, how would you eliminate? What would you do to eliminate x on this one?
Multiply the first equation by -25.
Excellent. Mm-hmm. Yep. And then how can I eliminate y from this one? Anybody want to give me that suggestion? Sadie?
Multiply the first equation by -25.
Take your pick. Those are your best options if you're going to eliminate. Okay? Now this one I get a decimal. You guys get a decimal for this one? Once you multiply equation 1 to get one of the variables eliminated, it comes up pretty quickly. I haven't solved for y yet. I just solved for x. We're not going to have any time to solve for y because it's time to go. We're just going to solve for x and we're done with it. But for x, I get 133 and 1/3 milliliters. Okay? I'll let you figure out why on that one. Work on them. We'll revisit it on Wednesday, okay? Nice work, everybody. Good job.